Welcome to the fourth video in our Class 20 series of lecture videos. Today we're going to talk about the ring opening under acidic conditions for these epoxides. So if we have this symmetric epoxide, this ethylene oxide, and we put it in methanol with a little catalytic sulfuric acid, we actually get the epoxide to open and we add this methoxy group. How does this happen? Well, we protonate our oxygen atom of our epoxide, and then a molecule of methanol adds in and opens it in an SN2-like fashion, and then is simply deprotonated to give us our product. In terms of asymmetric epoxide openings under acidic conditions, it kind of goes opposite what one might expect. We have our epoxide. Here we've got a tertiary carbon. Here's a primary carbon. We protonate it, and our methoxy group goes to the more sterically hindered carbon. Of course, this is somewhat consistent with our ideas about SN1 because once we protonate that epoxide, it can simply open and give us a tertiary carbocation to which the methanol will add and then be deprotonated. Usually by another molecule of methanol to give protonated methanol and the HSO4 minus anion, and of course our product. What is unusual about this is the fact that if you have an epoxide with a stereocenter, you get inversion of that stereocenter, much like the SN2 mechanism. But this is somewhat explainable through an SN1 type mechanism. So here we have an optically active pure enantiomer epoxide. We put it in methanol with catalytic sulfuric acid, and we get inversion of the stereochemistry, almost as though our methanol attacked that tertiary carbon in SN2-like fashion. There's no racemization, so we ask why, and our answer is that once our epoxide opens, that top face is shielded by our hydroxyl group, and then the methanol has no choice but to add to the bottom lobe of our empty p orbital on our carbocation. So as the epoxide opens, close association with that hydroxyl group may shield the top face. So be familiar with the two methods for opening epoxides. The method where you use a nucleophile and you go by SN2, usually the nucleophile is a weak base or could be a strong base. And then the other method we just talked about is the opening of epoxides under acidic conditions. Just to let you know, epoxides can be found in nature. Here's the natural molecule, this cis-7,8 epoxy 2-methyl octadecane, or just parlor. It's a sex pheromone of the gypsy moth. So even nature makes these unusual three-membered rings containing oxygen. With that, good luck on the question, and I'll see you for Class 21 lecture videos.